Hi gentlemen, these will be your notes for Unit 1, Day 2. If you would like to see the warm-up worked out or the review question or any homework questions we went over during class, just look at the finished notes that are directly above the video notes. Today we are going to perform operations on fractions. So when I talk about operations, I'm talking about addition, subtraction, multiplication, and division. We are going to be able to simplify expressions using the order of operations. We're going to talk about algebraic expressions. Those are any expressions that contain a variable. And we're going to be able to translate phrases into algebraic expressions and equations. So the first thing we're going to talk about today is how to simplify a fraction. So you guys know how to simplify a fraction. The way we're going to do it is going to be very similar to how you did in the past, but I'm also going to show you another way of thinking about it. So we're going to start with one you know. So 2 over 2, you guys know, means 2 divided by 2, and 2 divided by 2 is 1. So a number over itself is always going to make 1. How you guys probably learned about simplifying fractions or reducing fractions in the past is if you had a fraction like 12 over 42, you would think, okay, what number can I divide both fractions by? And both of these are divisible by 6, so you could divide the numerator and the denominator by 6, and you would get 2 over 7. So 12 over 42 reduces to 2 over 7. That is correct. Another way of thinking about this is you could take 12 over 42, and remember last class when we did prime factorizations? Well, you can just take some factors of 12. So you know that 12 is 2 times 6, and you know that 42 is 7 times 6. And notice 2 over 2 is 1. Well, 6 over 6 is also 1. So now this can become 2 over 7 times 1, and anything times 1 is itself. So that's another way of thinking about how to reduce fractions. You can break up the numerator and denominator into its factors, and then if you have a number over itself, it reduces to 1. So you guys can go ahead and try and reduce these two fractions. You can check your work against the finished notes. Multiplying fractions. When we are multiplying fractions, this is the easiest operation to do. You multiply straight across the numerators, which is the top of the fractions, and you multiply straight across the denominators, which is the bottom of the fractions. So you multiply straight across the numerators and straight across the denominators. So for the first one, we can take 5 times 3 over 9 times 10, so we would have 15 over 90, and then you can reduce. Both of these you can break up into 15 is 5 times 3, and 90 is 5 times 18. So you could reduce the 5 and the 5, because 5 divided by 5 is 1, and this is going to be 3 over 18. If you want to reduce at the start of the problem, so this is 5 over 9 times 3 over 10, any numerator, when you're multiplying, can simplify with any denominator. So 5 over 10 can reduce. So both of these are divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And then also the other numerator and denominator pair can reduce. So 3 over 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I have the fraction 1/3 times 1/2, which again you multiply straight across the numerators, straight across the denominators, and you end up with 1/6. So you guys can try this one, and you can check your work against the finished notes. If we have something like 6 times 2/3, you can make anything into a fraction by putting a 1 underneath it. So this is the same thing as 6 over 1 times 2/3. So you guys can go ahead and try that. Remember that you multiply straight across the numerators, straight across the denominators, and you can check your work against the finished notes. If you are given a mixed number, and you are multiplying or dividing, adding or subtracting, I think the easiest way to do this is to change it into an improper fraction. So any mixed numbers we're going to change into improper fractions. And so remember how to do this is you take the denominator and you multiply it by the whole number, and then you add the numerator. So we're going to take 3 times 8, and then after we're done, we're going to add 7. and then the denominator stays the same. So 3 times 8 is 24, and 24 plus 7 is 31. So this is going to become 31/8. So this problem is 31/8 times 5/6. And neither the numerator nor the denominators can simplify with each other or reduce with each other. So we're going to end up with 31 times 5, which is 155. So we have 155 over 48. And I'm okay with you guys leaving it as an improper fraction. Dividing fractions is the same almost as multiplying fractions. When you divide fractions, you are actually going to multiply by the reciprocal of the second fraction. So you guys might have learned this as copy dot flip when you're dividing fractions. Another way of thinking about this is if you want to take 2 and you wanted to divide it into a half, so you have 2 wholes, right? And you want to divide that into, you want to divide each of those into halves. So here's a half, here's a half. How many total pieces would you have now? You would have 4 total pieces. Well, what would you have to do for 2 divided by half to get 4? You're going to take 2 times the reciprocal of the second fraction. And then remember, you can put a 1 underneath the 2. And when you multiply straight across, you would get 4. So that's kind of why fraction division works the way it works. So on that first one, we would have 1/2, and then we multiply by the reciprocal of the second fraction. So it would be 1/2 times 5/4. And then remember, when you multiply fractions, it's straight across the numerators, straight across the denominators, and we would get 5/8. So you guys can go ahead and try this one, and you can check your work against the finished notes. On the next one, remember, we can make it 5/1. So this would be 5/1 times the reciprocal of the second fraction, which is 3/2, and then multiply straight across the numerator, straight across the denominator, and you guys can check your work on that against the finished notes. On the next one, we have another mixed number, so we're going to change it to improper. So this is going to be 6 times 5, so take the denominator times the whole number, and then add the numerator, and then add 2, and then the denominator stays the same. So this is going to become 32/5. So this problem is going to be 32/5 times 20 is 20/1 if you want to make it into a fraction. So his reciprocal is going to be 1/20. This does reduce, so 32 divided by 2 is 16. 20 divided by 2 is 16. It reduces again. 16 divided by 2 is 8. 10 divided by 2 is 5. So this is going to become 8/5 times 1/5, which is going to be 8/25. When you are adding fractions, you need a common denominator. So adding and subtracting fractions, you need a common denominator. So if you look at our first ones, we have a common denominator. And then you just add the numerators once you have a common denominator. So 2 plus 7 is 9, and 9 plus 8 is 17. So this is going to be 17/10. The denominator stays the same. On the second one, we need a common denominator because the two denominators are 8 and 2. So my common denominator can be 8. I need to change that 2 into an 8. So in order to do that, I can multiply it by 4. But in order to keep my fraction equivalent, whatever I do to the denominator, I have to do to the numerator. So I'm going to multiply the top and the bottom by 4. So now I have 3/8 plus 4/8. And now I have a common denominator, so I can just add the numerators. So this would be 7/8. You guys can go ahead and try the next one. You can check your answer against the finished notes. For the mixed numbers, again, I think the quickest way to do it is to change them into impropers. So this would be 72 plus 3, so this would be 75/8, then minus 30 plus 5 would be 35/6. Their common denominator could be 24, because both 6 and 8, when I multiply them by different numbers, I can get 24. And then 75 times 3 would be 225, and then minus 35 times 4 would be 140. So this would be 140 over 24. So again, I multiplied the 6 times 4 to get 24, and I multiplied the 8 times 3 to get 24. And then we're just going to subtract the numerators. So 225 minus 140, and I would get 85. So this is going to be 85 over 24, if my math is correct. So this was adding and subtracting fractions, so you would add or subtract the numerators. Equivalent fractions are any fractions that when you reduce them, they're the exact same value. So 4/8, if I reduce this, I could reduce it to 2/4, and I could reduce it again to 1/2. All of those are equivalent fractions because they have the same value once I reduce. Exponential notation. So you guys probably remember how to do this. If I had something like 4 to the 3rd power, we call 4 the base, and 3 is the exponent. And remember, the exponent tells you how many times you're going to multiply the base. So 4 to the 3rd power means 4 times 4 times 4. 4 times 4 is 16, and then 16 times 4 is 64. So 4 to the 3rd power would be 64. So you guys can go ahead and try A and B. You can check your work against the finished notes. If it's a fraction, it works the same way. This would be 3/4 times 3/4 times 3/4. And again, when you're multiplying fractions, you multiply straight across the numerators, straight across the denominators, and this would be 27 over 64. 64 to the 1st power, well, we're just going to take 64 and multiply it one time. Well, that's just 64. So you guys can go ahead and try the ones on these pages. You guys already did these two above, and we did this one together. So let's change this as 3 over 4 to the 5th power. So you guys can try those two, and you can check them against the notes. Order of operations. You guys probably remember something along the lines of learning PEMDAS. PEMDAS isn't my favorite because I think you can get confused using PEMDAS, but the idea is okay. So the very first thing you're going to do is the P stands for parentheses. So anything inside parentheses, you're going to work out first. The E stands for exponents. So after you're done with parentheses, anything with an exponent, you're going to do next. Step 3, the M and the D go together for step 3. So it's multiply and divide. And you're going to go in order from left to right. So whatever comes first, you're going to do first. So if division comes first, divide first. If multiplication comes first, you're going to multiply first. So for instance, if I had 3 times 6 divided by 2, notice from left to right, multiplication comes first. So I'm going to multiply first. So 3 times 6 is 18, and then we're going to divide by 2. If division came first, so let's say I have 6 divided by 3 times 4. Notice this time division comes first. So I'm going to do the divide step first. 6 divided by 3 is 2, and then 2 times 4 is 8. And then the last step in order of operations is the AS, and that step goes together as well, so addition and subtraction. And again, it works the same way as multiplication and division. You're going to go from left to right. So whatever comes first, do first. So if addition comes first, add first. If subtraction comes first, subtract first from left to right. So let's go ahead and try one. So if we're doing order of operations on A, our 3 operations are multiplication, subtraction, and division. Multiplication and division would come before subtraction. Multiplication comes first, so we're going to do that step first. So 5 times 6 is 30. So now I have 30 minus 8 divided by 4. And again, division comes before subtraction, so I'm going to divide first. So this is going to be 30 minus 8 divided by 4 is 2. And then our last step is subtraction, and 30 minus 2 is going to be 28. Our next one, we have parentheses, so we're going to do everything inside the parentheses first. Within the parentheses, I have a subtraction, multiplication, and I also have an exponent. The exponent is going to come first. So this is going to be 8 minus 3 times 2, and then 3 to the 2nd power means 3 times 3, so I'm going to have 9. I still have parentheses, so I'm going to do parentheses still. I have subtraction, multiplication, and addition. I'm going to do the multiplication first because that's what comes next in order of operations. So this is going to be 8 minus 6 plus 9. And then we have subtraction and addition left in the parentheses. Subtraction comes first in order from left to right, so I'm going to subtract first. So 8 minus 6 is 2, so this is going to be 5 times 2 plus 9. I still have parentheses, but the only operation left is addition. So this is going to be 5 times 11, and 5 times 11 is 55. I'm going to have you guys try C. You can check it against the finished notes. When order of operations comes with a fraction, you simplify the numerator first. You simplify the denominator. And then you can simplify the overall fraction as the last step. So I have an absolute value. Absolute value you kind of can view as parentheses. So I have 24 minus the absolute value. I'm going to do the exponent first. 2 to the third power is 8. So this is going to be 24 minus the absolute value of 5 minus 8. All over the denominator. The first step in the denominator is going to be multiplication. So this is going to be 13 minus 6. Keep working. 5 minus 8, if you guys remember how to do this, we're going to review integers soon. That's going to be negative 3. And then all over, 13 minus 6 is 7. The absolute value of negative 3 is 3, so it's going to be 24 minus 3 over 7, which is going to be 21 over 7. And then our very last step is we can reduce that fraction, and that would be 3. Variables and algebraic expressions. Variables represent any number. And we use letters to represent this. So like X could be a variable, Y can be a variable, A can be a variable. Any letter can represent variables. So algebraic expressions are any statements with variables. So 3x plus 2 is an algebraic expression. xy minus z over 4 is an algebraic expression. Algebraic expressions typically don't have less than or equal to, greater than or equal to, less than, greater than, equal signs. They're just expressions without a mathematical symbol other than the operations. So if we're going to evaluate algebraic expressions, what I always do is when we're going to substitute in the value, we're going to substitute in parentheses. So whenever you substitute a number, substitute it in with parentheses. So in the first one, we have 3x, so it's going to be 3, and then since I'm substituting 5 in for x, I'm going to put the 5 in parentheses. That sometimes helps you to figure out what you need to do next. And then when I say 3 parentheses 5, that means 3 times 5. So that's going to be 15. So go ahead and try with 4y. On C, we're going to substitute in twice. So this is going to be 3 times 5 minus 4. And then I'm going to substitute in the 3 for the y. And so this is going to be, order of operations says multiply first. So 15 minus 12, which is going to give me 3. So you guys go ahead and try D. You can check it against the finished notes. E, we need to be careful. So remember when I said when you substitute in, you're going to put in parentheses. So it's going to be 3. Then I'm going to substitute in 5, and I'm going to put it in parentheses. Notice order of operations says we need to do exponents first before we do the multiply step. So the exponent says 5 to the second power. 5 to the second power is 25. I'm going to keep that in parentheses so I remember that the operation right there is multiply. And then 3 times 25 is 75. And then you guys go ahead and try F, and you can check it against the finished notes. Remember when it's a fraction, simplify the numerator, simplify the denominator, and then you can simplify the overall fraction. Equations and solutions. So if we want to know if a number is a solution of an equation, we're just going to plug it in. And for this to be true, the left side needs to be equal to the right side for x equals 3 to be a solution. So the two sides need to be equivalent or equal. We need to get the same number on both sides. So let's try this. Is 3 a solution? So we're going to plug in 3 for each x. And remember, when we substitute in, put in parentheses. So 4 times 3 minus 10, is that equal to 5 times 3 minus 13? Well, order of operations, we're going to multiply first. So that's 12 minus 10 equals, multiply, 15 minus 13. So does 2 equal 2? Yes. So x equals 3 is a solution. So you guys can go ahead and try, is 8 a solution? And you can check your work against the finished notes. So we have a lot of different verbal expressions that can be translated into algebraic expressions. So if we want to talk about adding two numbers together, words that mean add are sum, plus, added to, more than. Notice it doesn't say is more than, it just says more than. So 5 more than 3 would be 8, you're adding there. Increased by, total, all of those words mean that you're going to be adding. Subtraction has its own list of words. So difference of, minus, subtracted from, less than. Notice that is not is less than, it's just less than. Decreased by, less. All of those words can mean subtraction. Multiplication has its own list as well. Product, times, multiply, twice, of. Divisions words could be quotient, divide, into, ratio, divided by. And then to say that two things are equal to each other, you can say the sum of x and 2 equals, gives, is, was, should be, yields, amounts to, represents, is the same as. So let's take a look at some of these examples. The sum, and remember sum is an addition problem, of a number and 10. Well, when they just say a number, you get to pick the variable that you want to be represented by the number. I typically pick x, but you can pick your favorite letter. So the sum of a number and 10 would be x plus 10. Twice a number, so if you wanted to do twice 5, that would be 2 times 5. So when you see twice a number, it means 2 times the number. So you could write it as 2x. Product, remember product is in the multiplication column. So the product of a number and 7. A number again is a variable, so you can pick your variable. So I'm going to write 7y. When we are writing multiplication with variables and numbers, the number is going to go in front of the variable. That's just the way we write it in math. 7 times a number increased by 13. We need to be careful with the order of operations. So we want to do 7 times a number. That's multiply. So that could be 7x. And then we're going to increase it by 13. Remember, increased by is the addition. So then it's going to be plus 13. Quotient is in the division column. So this is going to be dividing a number and 9. So let's just call our number a. So that could be a over 9, or you could write it as a divided by 9. But typically we're going to use the fraction. 8 less than a number. These are the ones that usually have the most mistakes made on them, is the less than. You need to make sure you put it in the right number. So 8 less than 12. You guys probably know what that would be. What would be 8 fewer than 12 or 8 less than 12? You know that you would get the number 4. In order to write that, would we do 12 minus 8 or 8 minus 12? Well, we would do 12 minus 8. So we're going to do 8 less than a number. Our number we're going to call x, and 8 less than that, you would subtract 8 from it. So it would be x minus 8. So you guys can go ahead and try these, and you can check your work against the finished notes. So gentlemen, for your homework, you have 2 sections, but it's the same as before. So you're going to choose 2 problems from each of the number groupings in 1.3 and 2 problems from each of the number groupings in 1.4. If you guys have any